So we're going to start chapter 4. Chapter 4 is graphing and optimization. Section 1 talks about first derivatives and graphs. We already talked about how to do derivatives. Hopefully we're totally good with that. We understand what derivatives are, how to take it, all those wonderful things. The question is, do we remember it? Are we comfortable with how to do it? Those are the kind of things we're going to work on today. So if you're still struggling with derivatives, that's going to be a problem. If you're still struggling with algebra, that's going to be a problem. And if you're still struggling with graphing, that's going to be a problem. And new stuff's not too bad. Just use it at all. So what's the first derivative? The first derivative is associated with slope of a graph, and we did derivatives like crazy so far. It is reasonable to expect that the first derivative is also related to other properties of a graph. In this section, we're going to examine how information about the first derivative reveals insight into the shape of a graph of the function. In particular, we study methods for finding absolute max, mins, valuable information used to make decisions in manufacturing, pharmaceuticals, marketing, and other areas. Okay? The way they like to explain it is with sign charts. I'm going to explain sign charts and what it means and how they're doing it. I'm not a huge fan of sign charts. I appreciate it. It does help. But I like seeing it and graphing it more than just looking at the sign charts. So we're going to kind of do both of them. And we did talk about sign charts back in section 2.3. And I'll give you some examples in the future. Okay? So let me back up just a little bit and talk about what we're going to do. Let me give you a little overview before we even get started. Okay? What we're going to do is we're going to basically have a picture of a graph. Okay? And that graph, who knows what it's going to look like. It may look like this or it may look like whatever, different shapes. Okay? But let's say we had a graph that looked really intricate like this. This is a graph of the original, not a graph of the derivative, graph of the original. Okay? As we look at this crazy graph, we're going to notice that there are high points and low points. Okay? So for example, this would be a local max, a high point. Y to the left and right or lower. This would be a local max. Y to the left and right or lower. It's a high point. That would be a local max. We also have some minimums, some low points. This would be a local min. Y to the right is lower. That's an end point. This would be a local min. Y to the left and right or lower. It's like a bottom. This would be a local min. That would be a local min. That just goes up forever. Okay? So in this graph, we have highs and lows. Now, if we're talking about money, this may be the maximum revenue. Maximizing profit, right? Or minimizing cost. Those are the kind of things we're doing. Now, how we do it, let me give you like the basic steps. What we're going to do today is, number one, we're going to take the derivative. Now, let me be very clear, we're trying to find the highs and lows, the extrema, max, mins, of the original. How do you find the extrema, the max and mins of the original? You take the derivative, and then step 2, set the derivative equal to 0 and solve. Okay? When you set the derivative equal to 0, what we're going to find are possible, not for sure, but possible highs and lows. We're going to find these possible highs and lows. Why does that work? Well, derivative is rate of change. Derivative is slope, right? So the slope is 0 at these points. So if I take the derivative, we're finding when the slope is 0 and finding where those points are. Now, it may or may not work because there's other things that could be going on. There could be asymptotes, there could be other things going on. But that's one way to find those possible highs and lows. Take the derivative, set equal to 0 and solve. Which means you have to, 1, know how to take the derivative. 2, know your algebra to solve it, and that's what we're going to test today. And then 3, we want to graph to see if we're right. The other thing we're going to do, number 3, is we're going to look at the derivative and see if there's any place the derivative is undefined. Now, what does undefined mean? Undefined basically means dividing by 0. That's really what we're going to look for. Take the derivative. Is there any number that would make it dividing by 0? And we'll do examples of this, so don't worry. And then the fourth thing, which they don't really talk about in this section, I'll probably bring up later, is we're going to look at endpoints. We're going to look to see if there's any endpoints. What I mean is where it starts and where it ends, or if it doesn't end. We're going to look at endpoints. That could also be a possible extrema, a possible max, or a possible min. Okay? And then the last thing we're going to do is we're going to graph the original. Now, graphing the original won't be that bad because we just put it in the calculator. The part you have to think about is the window. The window. Now I know what I'm going to go look for. I need to make an appropriate window to see it. If I can't see it, I can't see if it's a max or a min. Now, they're going to be using sign charts, and we'll talk about that as we do the examples. The sign charts are a good way to see if it's a max or a min by looking at the derivative without even graphing it. I prefer to graph it, and we'll do both. Okay? So before we get there, let's practice the steps. So all these steps are going to come in later. We're going to work our way up to it. They like to build to it. So let's practice. Okay? So the first example that we're going to do is, let's say we have the function x cubed minus 3x. Okay? That is my original function. And again, they're going to add it later. We're going to talk about it now. We're trying to find the highs and lows, the maxes of that graph. Okay? Now, I can simply just graph it, assuming we knew the window. Let's go to our calculator. Go to y equals, in y1, let's graph the original. The original is x raised to the third minus 3x. So we're going to graph the original. We're going to graph the original. To make sure we all have an appropriate window, we're going to hit zoom 6. Zoom 6. That gives us a standard window, 10 by 10 by 10. Okay? So does everybody have this graph? Everybody have it? Okay. Now, just do a quick sketch. Doesn't have to be perfect, just a quick sketch. And looking at the original graph of the original, do you see a max and a min? A high point we'll call local max, a low point we'll call local min. Does everybody see that? The question is, where is it? Now I can sit with my calculator and try to find it, but what we're going to do is use derivatives to find those points. Use derivatives to find those points. Okay? Now again, they teach all this later. We're doing it right off the bat. So the first thing I want you to do is take the derivative, set it equal to 0, and solve. Take the derivative, set it equal to 0, and solve. Take the derivative, set it equal to 0, and solve. If you don't know how to take the derivative, there's your first problem. If you don't know how to do the algebra, there's your other problem. That's what's going to be our issues today. All right, so let's see how we're doing.
Oh, I'm sorry.
Okay. So if I take the derivative, what's the derivative?
3x squared minus 2.
Equals 0. So we take the derivative, set it equal to 0. Are we okay? Then we solve. How do we solve? We can add 3, 3x squared equals 3, divide by 3, divide by 3. X squared equals 1. X equals what?
1 and negative 1.
Positive and negative 1. So we have two places. Now again, these are possible, not for sure, but if you totally forgot how to do your algebra, you got a problem, okay? Somebody else could have factored, so maybe one of you did, some of you pulled out the 3, and then maybe factor this to x minus 1, x plus 1. You could have done the algebra this way. Both ways are great. Bottom line, you get the same answer both ways. Okay? So either way, we have 2 possible extrema, 2 possible maxes and mins. How did we do that? We took the derivative, set equal to 0 or solve. If you're having a problem with the algebra, that's why we spend so much time in Appendix A and Chapter 1. Even though it's not part of this class, you got to know your algebra. We good? Now, I'm going to kind of go through this. The other thing we're going to look at is, let's just look at the derivative. Just look at the derivative. Is there any place that it's dividing by x, or is there any even dividing going on at all? No. So is there any chance for being undefined? No. And if you're a little unsure what that is, I'll go over an example. But there's none as far as trying to go undefined. There's nothing I have to worry about there. So far, I only have 2 points. And then the last thing we'll check, if there's any endpoints. And they didn't give us any endpoints, like it starts here or ends here. So there's no endpoints. Those are some things we'll throw in just to double check. So after all this, what's the only thing we found? 1 and negative 1. Are we okay? So we're going to make a table. Negative 1 and 1. That's where there's a possible max or min, a possible extrema. Are we okay? Yep.
Well, how do you know about the endpoints again?
It has to be given. They didn't give us any. So
it has to be given.
Yep.
Okay,
Good
got
question.
it.
Now, I'm trying to find the maxes and mins, extrema, of the original or of the derivative? Of the original. So once I find these points, negative 1 and 1, am I going to plug it back to the original or plug it back to the derivative? Original. Why? It's all about the original. We use the derivative to find it, but it's all about the derivative. So hit second graph for the table. Second graph for the table. Type in negative 1, you get 2. So we're going to go look at negative 1, 2. Type in 1. 1, negative 2. Those are the possible extrema, possible highs and lows. How do I know if they are? I'm going to go check. I'm going to go look. Okay? So let's go to the graph. And if I look at my graph, negative 1, 2, do we have a max or a min? What do we have? A max. And right now we're going to call it local max. Again, all this will be explained a little later. But the reason why it's called a local max is it's a max, right? But we're going to learn something called absolute max, which is the highest of all the maxes later. Okay? So we have a local max at negative 1, 2. And what do we have at 1, negative 2? Local min. Okay? So in order to do this problem, you need derivatives, you need algebra, you need to be able to graph. Those are the 3 basics that you need. Without that, you're going to struggle. Once you do it, it's pretty easy. And I'm going to show you a really cool trick. You have the graph here. Everybody hit second trace. Second trace. When you hit second trace, choose number 1 for value. Number 1 for value. And what was the first number we found?
Negative 1.
Type in negative 1, and it will go right to it. It's blinking. So you can verify that's a max. Type in 1, enter. It will go right to it, 1, negative 2. So that's a great way to check your work as long as you have the graph. Are we okay? That's the big part about chapter 4. It's second trace, number 1 for value, and then type in negative 1, and it goes right to it. Type in 1, and it goes to it. And again, take those notes. Just because I don't write it down doesn't mean you have to write it down. Second trace, 1 for value, type in the number. Okay? Questions? Now, let's go back to the notes. So, again, take the derivative, set it equal to 0. Now, when we take the derivative, set it equal to 0, what we found was -1 and 1, okay? They're using a sign chart. Let me explain what a sign chart does. Something interesting about derivatives, not the original, derivatives, is if you plug a number into the derivative, and the result is positive, that's when your graph is increasing. If you plug a number into the derivative and your result is negative, that's where the graph is decreasing. If you plug a number into the derivative and it's positive, that's where the graph is increasing. Okay? So what do they say? They're saying is by the derivative, if you find your points, -1 and 1, and you know anything less than 1, when you plug into the derivative gives you positive, it's going up, increasing. Then, to the right of -1, like let's say you plugged in 0, you get a negative result, that's where it's decreasing. Oh, if something increases, then decreases, what did you just make? You just made a maximum. If it increases, then decreases, you have a maximum. If it decreases, then increases, what did you just make? A minimum. So by the derivative, you can then figure out if you have a max or min. Okay? So again, if you're a little confused by that, how do they make a sign chart? Here's how they make a sign chart. What were the two numbers that we found? -1 and 1. Are we okay? So we're going to draw a line here and a line here. We're going to go to our calculator, go to y1, but don't put in the original, put in the derivative. What's the derivative? 3x squared minus 3. So in the calculator, we put the derivative. Okay? Go to the table, second graph. Now, give me some numbers that are less than -1. Give me some numbers that are less than -1. -2, -5, -3. Okay? All of those results are what? Positive. So everything on this side is going to be positive. That means the graph is increasing. Okay? Give me some numbers. Let's delete those. Give me some numbers between -1 and 1. 0, -0.5, 0.5, -0.25, 0.25. All of those numbers are what? Negative. So the derivative is telling me increasing, then decreasing. What must happen at -1? What do we have at -1? It's a maximum. Why? Increasing, decreasing. And I can tell all that by the derivative. Okay? Now, give me some numbers greater than 1. Give me some numbers greater than 1. 2, 3, 4, 5, 6. All of those results are what? Positive, which means at that point the graph is going what? Up. So if it's going down and then up again, what do we have at 1? A minimum. Okay? Now, did we get that same answer by doing it this way? Absolutely. So the idea is that I like looking at the original, do the work, verify with the original. But you can also get the answer by plugging it into the derivative. That's the sign chart. Okay? You don't have to do both. You get the same answer both ways. You can have a preference, or you can do both to check. Are we okay? But the basics are the same. Derivative, set the derivative equal to 0, look at the derivatives undefined, see if there's any endpoints, and then draw the graph or do the sign chart. Yep.
How would the derivative be undefined?
We'll go through one of those. You'll see.
Okay.
Yeah, we'll get to one of those. Okay? So let's practice some more. So again, we talked about if the derivative is positive, that's where it's increasing. If the derivative is negative, that's where it's decreasing. Increasing is going upward, decreasing going downward into the derivative. So here's another one, okay? We're gonna step away a little bit from horizontal tangent lines. We'll bring that back in, but let's practice what we just did, and then I'll add the horizontal tangent lines to it. So here is the function ax minus x squared. I want you to go through the same steps. Take the derivative, set it equal to 0, and solve. See if there's any place the derivative is undefined. We don't have any endpoints, so we don't have to worry about that. But let's practice derivatives and algebra. Derivatives and algebra. I'm going to give you just a little bit of time, not a lot. This is really to see if you have it or not. You'll know pretty quickly if your derivatives are good and your algebra is good. Okay, so if we take the derivative, what do we get?
8 minus 2x.
Good. Set it equal to 0. Add 2x, add 2x. 8 equals 2x, divide by 2, divide by 2. Notice I'm showing my work, but I'm not going to sit here and explain how to solve for x. Okay, we all know how to do that. So we find that. Also, the other two little things we'll check. Is there any place we're dividing by x? Is there any place we're even dividing? Is there any chance of being undefined? No. And endpoints, they didn't give us any. So none. So really, the only place we could have a possible, remember I always say possible, we don't know for sure till we see it, is where? 4. Now, to find out where that is, we're going to take 4 and plug it into what? Plug 4 into the original. So if I plug 4 into the original, go to my calculator, type in 8x minus x squared, plug 4 into my original, what do we get for an answer? 60. Now, we need to see 4 comma 16 to decide, is it a max, is it a min, or maybe it's neither one. Who knows? Maybe it's not one. Okay? So in order to see it, here's the third piece. You need derivative, you need algebra, and you need to be able to graph. So the only thing I need to see is this point. So when I make my window, I need to see 4 on the x. So what should I start with? Maybe 0 to 8. Will that let me see 4? Yeah. So let's start with 0, and let's go to 8. Why did I choose that? So I can see 4. X is 4. So if I go, let's say by 2s, that will be my window. On my y, what do I need to see?
16.
So maybe go from 0 to 18, 20. All those things are good. I'm not going to go 0 to 10 because I won't see it. Does that make sense?
Mm-hmm.
So when you decide on your window, how do you figure your window out? It's what you need to see the point. Because what I'm interested in is 416, right there. What is going on at 416? And without an appropriate window, you'll never see it. Without an appropriate window, you'll never see it. So this method, you need to figure out the window. Okay? So let's go to our calculator. We decided we're going to go from 0 to 8, counting by 2s, 0 counting by. Now, if your window doesn't work, go back and change it. How do you know if it didn't work? If you don't see it, you didn't find it. You didn't get the right window. Hit graph. Do we see what's happening at 416? At 416, what do we have? What's that called? A local max. At 416, we have a local max. Now let me give you a definition of what is a max. A max is to the left is lower, to the right is lower, therefore it's a max. Now, let's see if you remember that calculator trick. Do the little calculator trick to put your little cursor on top of it. See if you remember the steps. Put your little cursor on top of it, just so you can verify it's true. What do we press? Second trace, number 1 for value. And what value do I want to see? 4. And at 4,16, we have a maximum. We have a maximum. Are we okay? Question? Now, let's incorporate the sign chart. Let's incorporate the sign chart. With the sign chart, what is the only number that we're concerned about? What's the only number that came up? 4. So we're going to pick numbers before 4, see what happens. We're going to pick numbers after 4, see what happens. But what are we plugging it into? The derivative. So let's go to the calculator. Change the y1 to the derivative. What was the derivative again?
8
Minus
minus 2x.
2x. And then we're going to pick numbers before 4 and after 4 and see what happens. So what are some numbers before 4?
Negative 2.
Negative 3, negative 2, 3, 2, 1. All of those results are what? Positive. So when I plug it into the derivative, all the results are positive. Now, and just interestingly enough, what happens when you plug in 4? You get 0. Isn't that what we figured out? What number makes it 0, right? So that's a good way to check. Give me some numbers after 4. And all those results are what? Since all those results are negative, positive means it's increasing, negative means it's decreasing. Therefore, what's going on at 4? It is a maximum. Sign charts make a little bit more sense? Okay? But again, keeping things straight. Original is what we're talking about. Derivatives are how we get there. Are we okay? Yep. The what? Oh, we'll get to that. Yeah, we'll get to when it's undefined. Until it happens, it's a little tough to see. Okay? Now, remember that their question here on the notes was which values of x correspond to the horizontal tangent lines? So what do I mean by that? We did the work. We got 4. We did it. We're trying to figure out what's happening. Before 4, it's increasing. After 4, it's decreasing. We worked all that out. And then when we did a sketch, the question said, where is there a horizontal tangent line? Remember, horizontal is a slope of 0, derivative equal to 0. That's what we found. Where does it happen? It happens at 4. At 4 is where that tangent line happens. And the equation of that tangent line is y equals 16. Y equals 16. Are we okay? So that's what that means. But the bottom line is a horizontal line is a slope of 0. Derivative is slope equal to 0. Okay? Now, what we're calling is critical numbers. So if a real number domain is a derivative equal to 0, or if the derivative does not exist, we call those critical numbers. Those are the important numbers that could or could not be extrema. Okay? So I've already got a bunch of questions on this. We're not there yet. We'll get to the undefined soon. Let's do one more. Okay? So one more practice, and we will get to the undefined, I promise. Very soon. Okay, so here's one more example, but I want you to do this on your own. We have the function 1 plus x cubed. Take the derivative, set equal to 0, see if it's undefined. There are no endpoints. Get the graph and make the sign chart. Get the graph and make the sign chart. C, which means a C. You can't see it, but that message will be at the top. That's what we're having before there. Okay, about 1 more minute to see where we're at. Okay, so we take the derivative. Derivative of 1 is 0. Derivative of x cubed is 3x squared. Set that equal to 0, and you get x equals 0. So only one place we need to go look. Excuse me, thank you. There is 3x squared. There's no dividing by x. There's no chance of dividing by 0. So there's nothing to worry about it defined. And as far as endpoints, they didn't give us any. If they did say that this is only good from 0 to 4, something like that, we would graph that way and check those out. So the only place I need to go look is 0. And when you plug 0 into the original, what do you get? 1. So the place I need to look is 0, 1. Now, in order to see it, I need to build a window around it. Okay? So this is where some of you may be struggling, is the window part. As far as the x, I need to see 0. So I should go from what to what? Yeah, maybe -2 to 2. I would just say the more you do, the better. I'm going to go -5 to 5. If you did -10 to 10 or -2 to 2, all those will work. But give yourself some room. That's all I'm going to say. Same thing with the y. What do I need to see on the y? 1. So I'm going to do the same thing. I'm going to go -5 to 5. Again, if you did a different window, that is totally okay. As long as you can see that point that we're interested in, that's the bottom line. My advice is to give yourself some room. Give yourself some room so you can actually see it and what's going on around it. So there's no hard rule of what to do. Just go around it.
I could do from 0 to 5.
If you did 0 to 5, you're cutting 0. So don't you want to see a little bit to the left? You need to see the point. You need to go around. You can go -10 to 10. You can go -100 to 100. You got to see 0. Okay? But just, I'm saying give yourself a little cushion. Just don't go too much. So y, put the original in. 1 plus x raised to the third. I'm going to use a window of -5 to 5 counting by ones, -5 to 5 counting by ones. If you did a different window, it's okay. You don't have to have the same window as me. You just need to be able to see the point. 0, 1. Hit graph. 0, 1 is right there. Can we see that point clearly? Does your graph allow you to see it clearly? Are we okay? Does everyone have the picture? Okay. Put your dot on 0, 1. Is it a max or a min?
Max.
Is it a top of a mountain, bottom of a valley? What is it? It's neither one. Remember we said these are possible maxes and mins. Are they for sure? No. That's why we have to verify it with the graph or with the sign chart. So it still gives us a horizontal slope. It's just not a max or a min. So this is neither. This is neither max nor min. It's no guarantee. That's why you have to verify it by the picture or verify it by that. It's going to have a horizontal slope, but it doesn't mean it's going to be a max or a min. Now, if I did this with the sign chart, which is another way to verify this, what number am I concerned with? What number did we find?
0.
0. And remember, for the sign chart, are we plugging into the original or we're plugging into the derivative?
Derivative.
The derivative. So what's the derivative of this one?
3x squared.
3x squared. Give me some numbers before 0. -1, -2, -3, -4. All those results are what?
Positive.
Which means the graph is increasing. Now give me some numbers after 0.
1, 2, 3.
What do you notice?
Everything is positive.
They're still increasing. So if it's increasing and increasing, does that make a max or a min? It doesn't make either one. Increasing, decreasing makes a max. Decreasing, increasing makes a min. So that's a quick way to verify there is no max or min. Are we okay? Yeah, more examples the better. There's your slide on that, verifying everything we did. Now, you've been asking for it, and now after you have it, you're not going to want it. But here's your example. I'm only going to give you a little head start. Just to verify your derivative part and algebra part. I'm not going to give you long. I'm only going to give you just a couple minutes. But go ahead and try this one. F of x equals 1 minus x raised to the 1/3.
Chain rule.
more minute. Okay, so to take the derivative, guess what? What do we need to do? Chain rule. So everything we learned on the last part continues and keeps moving forward. So this would be 1/3. Inside stays the same, 1 minus x. Subtract 1, you get negative 2/3. Derivative of the inside is -1. So you have to know your derivatives. You have to know your derivatives. Chain rule, product rule, quotient rule, special cases, everything is fair game. Okay? Now, also, we talked a lot about simplifying. Why? It's easier to do the algebra if you simplify. 1/3 times -1 is -1/3. That -2/3 goes to the denominator. 1 minus x to the 2/3. So you need to know how to do the derivative. You need to know how to do the derivative. You need to know your algebra. Now, once you have the derivative, we're supposed to set it equal to what?
To 0.
0. So let's stop there for a second and let's talk about the algebra. How do I solve -1/3 over 1 minus x raised to the 2/3 equals 0? One way is to make like a proportion. This is 0 over 1, cross multiply. If you do that, what's 1 minus x to the 2 raised to the 2/3 times 0? 0. X is gone. What happens when x is gone? There's nothing to solve for. So what's the answer? No solution. You can't solve if there is no x. So bottom line, if this was a graph, when will this graph touch 0? It will never touch 0. It never crosses 0. This, there is no answer. There's no solution. Okay, algebra, algebra, algebra. Now, remember the second thing we're supposed to look for? Looking at the derivative, is there any number that would make this undefined? Is
Yes.
there any number that would make this undefined? Undefined means dividing by 0. Again, first of all, there has to be some dividing. Is there any dividing going on?
Yeah.
Yep, and the x has to be in the denominator. Is there an x in the denominator? Yep. What number would make this undefined? Is it 1 or 0? 1. Why? What is 1 minus 1? 0. We can't have 0 in the denominator. If you put 0, 0 is fine. 1 minus 0 is 0. What number makes this 0? And the answer is what? 1. 1. So x equals 1 because 1 makes this undefined. And again, there are no endpoints, so we don't have to worry about that. Okay, so after working on all this, what's the only number we found? 1. And do we know if it's a max or min for sure? Do we know if it's a max or min for sure? No, we have to go check it. Question? Okay, so you cannot divide by 0. This bottom cannot be 0. What number makes this 0? 1 minus 1 is, so if x was 1, what's 1 minus 1?
0.
So if this was 2 minus x, what would x be? 2. If this was 5 minus x, what would x be? 5. It's 1 makes it 0. 1 makes it 0. You can't divide by 0, can't divide by 0.
Okay, so when plugged in the original to the graph, you got it's like 20 to 0. I mean, it crosses at 1 to 0. So I was confused, that's why.
This is a different, the last example. You're talking about this example?
Oh,
We
this
haven't graphed this one yet.
Yeah, that's why I was confused as I graphed it and I got like.
Yeah, we're gonna graph it next.
Okay.
So remember, is it a max or min for sure? We don't know. That's just a place to go look.
So when we have the division, we just have to make sure that like 1 makes the x 0?
Yeah.
So
You cannot
it will-
divide by 0.
Okay, so it will be 1. Got it.
Okay, now, where he's going to next, let's graph it. But in order to graph it, let's make our table. So when we make our table, what are we plugging 1 into? The original. So let's go to the original. Let's go to the original. Parentheses 1 minus x raised to the 1/3. Be careful typing it in. When you plug in 1 into the original, what do you get? 0. So I need to go find the point 1 comma 0. I need to go find the point 1 comma 0 and let's see what it is. Okay? Now, some of you are still stuck on the graphing part. I need to see 1, 0. So what would be a good x-axis to see 1, 0?
Second trace.
No, I have
Oh.
to see it first. I need a
Oh,
window.
okay.
So to see 1, I can go from what? 0 to 2. That will work, but don't you want to give yourself a little space? So maybe go -5 to 5. Again, 0 and 2 would get you there, but I want to see what's going on. Give us a little space around it. And then I need to see 0, so maybe the same thing. -5 to 5. Again, you don't have to. I just need to be able to see the space, the point I need to see. But I want to give myself a little cushion, because I want to see what this graph looks like. I want to see what's going on. Okay? And the point I'm concerned about is 1, 0. Let's see what's happening at 1, 0. So when I graph the original, -5 to 5, counting by ones, -5 to 5, counting by ones, hit graph. Let's see what we have there. It goes to 1, 0. And do we have a max or a min at that point? Do we have a max or a min? Neither one. Why? It's decreasing and still decreasing. What makes a max or a min? Decreasing, increasing, min. Increasing, decreasing, max. This goes down and down some more. So remember, these are possible maxes and mins, but does it mean for sure? No. And to verify that, so this is neither. To verify that, let's make a sign chart. When I make my sign chart, what's the number that I'm concerned with? What number did we find? 1. And we're plugging into the derivative. We plug it into the derivative. So I go to y equals, the derivative is -1/3 divided by, you can do the original as simplified, either one. 1 minus x raised to the 2/3. So we plug the derivative in y1. We plug the derivative in y1. And let's pick some numbers less than 1. What are some numbers less than 1?
-1.
-1, -2, -3, 0. All of those produce negatives. What would happen if I type in 1 into the derivative? What do you get when you type in 1 into the derivative? You get, what do you get in the calculator? What do you get in the calculator? Error, and error means undefined. Okay? So when you get an error, that could be undefined, or doesn't exist. Okay? Now, what are some numbers greater than 1? 2, 3, 4, 5, 6. All those results are what? Negative, which means the graph is decreasing, then decreasing some more, so it's neither. We okay? But when you look back on this problem, it's just like the other ones. Where do we have trouble? Derivatives, algebra, graphing. Derivative, algebra, graphing. It's not the new stuff. It's the derivative, algebra, and the graphing. It's always going to get back to the basics. Okay? So that's this one. We did the work. We found out that 1 makes the denominator 0. We did our sign chart, decreasing, decreasing. And we found out that it's neither. It's undefined there. Remember, these are possible, but doesn't mean for sure. Okay? Here's another one, and I'll even give you a head start. For this one, we have 1 over x minus 2. We have 1 over x minus 2. This implies you're going to be doing quotient rule. Remember how long quotient rule was? Could I rewrite this so I'm not doing quotient rule? Could I rewrite this so I'm not doing quotient rule? What could I do?
You multiply it on top.
Well, first of all, raise everything to the
Power.
1,
Yeah, and
and then when you move it up,
it will be a negative power.
it would be x minus 2 raised to the
Negative.
negative. Okay? Give that a try. Same thing. I'll give you a head start because, again, the problem is not the new stuff. The problem is derivative, algebra, graphing. Identifying local max or local min. I think you guys are doing a good job on that. It's the old stuff that keeps on popping up. Everything builds. Okay, so if we take the derivative, it's chain rule, -1, x minus 2 raised to the -2, derivative of the inside is 1. Again, this is why simplifying is important and why we spent some time on it. If you simplify this, this would be -1 over x minus 2 squared. Any questions on the derivative? Derivative. Now algebra. Okay? We set it equal to 0. Again, if this was like a proportion, if I set it equal to 0, it'd be 0 times x minus 2 squared. There's no x to solve. X doesn't equal 0 doesn't equal 1, doesn't work out. So this would be no solution. Are we okay there? 0 times x minus 2 is 0. That's -1. First of all, 0 does not equal -1. And once the x is gone, there's nothing to solve for. No solution doesn't work. Now, looking at the derivative, again, you want the practice with undefined. Here's your practice. Is there a number that makes this undefined? X equals 2. And again, there are no endpoints. But if they did give us endpoints like starting here, starting in there, we would add those. Okay? Questions? Through all the work, we found 2. We make our little table. I'm going to plug 2 into the original. Go to my calculator. My original is 1 divided by parenthesis, be careful, x minus 2. When you plug in 2, what do you get? Error. What does error mean? Undefined. Well, first of all, I know that's a problem, so I'm probably not going to get a max or a min. There's something special, something weird going on at 2. So let's go see. So if I want to see 2, what do you think a good window will be?
-2 to 1.
Maybe
Or
negative
-5.
5 to 5, negative 5 to 5, or go 10 all the way around. Again, where we really want to see is 2. This just gives me an idea of what's going on around it. If I graph in that same window, is there something going on at 2? Is there a max or a min at 2? Definitely not. What do we have at 2? A vertical asymptote. Okay? So again, it found something special, but it did not find a max or a min. So this would be neither. This is not a max nor a min, but we do have something special going on there, and that's a vertical asymptote. Are we okay? If we did the sign chart, the number we're concerned with is 2. We plug in the derivative. The derivative was -1 divided by parenthesis x minus 2 squared. If I plug in numbers before 2, 0, 1, -1, -2, we get negative, negative, negative. At 2, we get an error. After 2, 3, 4, 5, we get negatives again. It doesn't have that change to negative to positive. And that undefined, we have a vertical asymptote there. We okay? Not too bad? So that was, believe it or not, all the setup to get you ready for what we've been doing. They introduce it now. We've been doing it throughout. So there's all the work that we've been doing. 2 is the number. We notice there's a vertical asymptote. The sign chart's negative on both sides. Now, what we're doing, which we've already talked about, is trying to find extrema. Local max, local mins. So if I look at this picture real quick, I want to point at it. You tell me is a local max, a local min, or neither. So this point here, where it's decreasing, then decreasing again. What's that? Neither. This point here, where it's decreasing, then increasing. Min. We'll call it a local min. Here, where it's increasing, then decreasing. Local max. Here, where it's decreasing, then increasing. That's a local min as well. Here, where it's increasing, then increasing. Neither. This point, where it's increasing, then decreasing. Local max. Here, where it's decreasing, then decreasing. Neither. So just by looking at the original, you already know the answer. Just by looking at the original, you can tell. That's why I think it's important to graph the original. Okay? Local max, we talked about what it is. A local min, we talked about what it is. Those are called local extrema. We find the critical points, taking the derivative, say equal to 0, look at the derivative, see where it's undefined. And again, using the sign chart, if it's plugging into the derivative and you get negatives, then positives, that's decreasing and increasing, that gives you a minimum. That's a local mid. With your sign chart, if you have into the derivative positives for increasing, then on the other side negatives for decreasing, that is a local max. If you have increasing and then increasing, that's going to be neither. If you have decreasing then decreasing, that is going to be neither max nor min. And what we're finding when we take the derivative say equal to 0, we're finding the horizontal tangents. That's what we're really finding. That's why it equals 0. Local min, local max. Even if it's neither, we're still finding it, but it doesn't mean necessarily it's a max or a min. Same thing with these little weird ones. These are actually a picture of singular points where the derivative is undefined. You get that V-shaped. Local min, local max. And again, even finds increasing and decreasing ones. Doesn't mean they're maxes and mins. So finally, this is where they introduce all the steps. We've been doing all the steps since the beginning. So my only concern for you on this one is algebra, algebra, algebra. I bet the derivative you'll be okay, but I want you to find the extrema for f of x equals x cubed minus 6x squared plus 9x plus 1. Remember, take the derivative equal to 0, solve, see if there's any place undefined. There are no endpoints. Graph it and do the sign chart. For f of x equals x cubed minus 6x squared plus 9x plus 1. Give another minute, we'll see where you're at. All right, so we take the derivative and we get 3x squared minus 12x plus 9. We get the derivative correct. Then we set equal to 0, and if you don't know how to solve it, that's the major problem. In order to solve this, what do you have to do?
Factor.
Factor. So you can factor out a 3, which will leave you with x squared minus 4x plus 3. Then x squared minus 4x plus 3 factors to x minus 1 minus 3. So if you don't know how to factor, that's going to be a continual problem. That is the issue. It's not extrema, it's not derivatives, it's algebra, algebra, algebra. Then you set each piece equal to 0, x minus 1 equals 0, x minus 3 equals 0, add 1, x equals 1, add 3, x equals 3. Did anybody do it a different way? Yep.
I did different, but I only got.
It's two answers. You gotta make sure you get both. There is another way. I don't know if you remember, in all of your calculators, I gave you guys quadratic formula. So I don't know if anybody remembered, if you hit program quad form, because this is quadratic, A is 3, B is -12, C is 9, solutions 1 and 3. Now, if you're like, I don't need to learn factoring or everything I learned in college algebra, I can just push buttons in calculator, doesn't work that way. You didn't realize it just now. You got stuck. You may have given up. You'd have to leave the whole problem blank. Okay? This is a good way to check your work if it's quadratic or use quadratic formula. But bottom line is you need to know how to factor. Good question?
It's a different number in front, like a 4, it's 4 the x2.
If this was a 4,
Yeah.
no, it has to have an x in order to set equal to 0. So when you factor out a 3, it's just a 3. Okay? So the two numbers I'm concerned with are 1 and 3. If I look at the derivative, is there any place this could be undefined? Is there any place I'm dividing by x or any dividing at all?
No.
So none, we don't have to worry about that. And we weren't given any endpoints, so we don't have to worry about that. So what numbers am I concerned with? 1 and 3. So I have my points 1 and 3. And what am I going to plug them into? The original. All about the original. So I go to my y equals. I type in the original, which is x raised to the third minus 6x squared plus 9x plus 1. I go to the table. I type in 1 and 3, and I get the point 1 comma 5, and I get the point 3 comma 1. So those are the two places I need to see if it's an extrema, if it's a local max or if it's a local min. Those are the two places I need to see and go look to see if they're maxes or mins. Okay? So the other thing we're struggling with is the window. The other thing we're struggling with is the window. So if I need to see 1 and 3, what would be a good window? Should I go 1 to 3? No, I got to give some cushion.
0,
So maybe what?
0 to
You could do 0 to 5. You could do -10 to 10. However you want to do it. I'm going to go from -5 to 10. I'm going to give myself a good cushion that I'll see all this. But again, you decide what window you want to do. And I need to see on the y's 1 and 5. So you could do 0 to 6. But again, I want to give myself some cushion. I'm going to go -5 to 10 as well. Again, you don't have to have the same window as me. You just have to be able to comfortably see 1 comma 5, which will be about there, and 3 comma 1, which will be about there. Those are the points I really need to see. So that window would get me there. So if I go from -5 to 10, counting by 5s, -5 to 10, counting by 5s, however you want your window to be, as long as you see those 2 points clearly. Hit graph. And you'll notice the graph goes up, then it goes down, and then it goes up again. And again, you can hit second trace value at 1. What do we have at 1 comma 5? Local max. If I type in 3, what do I have at 3 comma 1? Local max. Okay? But again, you're really good at determining this is a local max and this is a local min. That's not the problem. The problem is derivative, algebra, graphing, the basics, the stuff we spend a lot of time on. Okay? If we get a sign chart, what numbers are we concerned with? 1 and 3. And with a sign chart, what are we plugging into? The derivative. With a sign chart, we're plugging in the derivative. So I go to y1, the derivative is 3x squared minus 12x plus 9. If I plug in numbers before 1, like -2, -1, and 0 into the derivative, those are positive. If I plug in numbers after 1, like 2, 2.5, 1.5, those are all negative. If I plug in numbers after 3, 4, 5, 6, 7, those are all positive. So it shows increasing, then decreasing, then increasing. There's your max, there's your min. Are we okay? That is the main part of 4.1. We have one more thing to look at. And it's kind of a little backwards, so I don't want it to be confusing, so I'm going to do my best to explain it clearly. The example we just did, we worked it all out, we did the factoring, we found our numbers, we did the sign charts. And to me, more importantly, we graphed it. And we could see we have a local max at 1,5 and a local min at 3,1. Okay? This is just saying that if a function is a polynomial degree of n greater than or equal to 1, then f has that most x-intercepts and n minus 1 local extrema. There is no guarantee that the nth degree polynomial has exactly n minus 1 local extrema, but there'll be no more than n minus 1 local extrema. We're just going to find it, but that's just one of those nice to knows. Now, this one is a little weird, so I want to explain this well. The graph shows the approximate rate of change of the price of eggs over a 70-month period, where ET is the price of a dozen eggs in dollars, and T is the time in months. Let me stop for a second. Do we have a graph of the original? Or since it says rate of change, we have a graph of the derivative? What do we have a graph of? Okay, so let's be very clear. This is not a graph of the original. It's a graph of the derivative. Are we okay? Now, since it's a graph of derivative, every time we do the derivative, what do we set it equal to? 0. This line represents 0. This line represents 0. So where will I have possible extrema? Where is the derivative equal to 0? Which numbers?
10.
10 and 50. Are we okay with that? Because we're looking at a derivative equal to 0 are where my possible maxes and mins are. So my maxes will be at 10 and 50. Good so far? Now, since this is the derivative, anything below 0 means that my result is negative. When a result is negative, are you increasing or decreasing? Decreasing. So this is decreasing from 0 to 10. And it's decreasing from 50 on. Anything above 0 means where my derivative is positive. When your derivative is positive is when your graph is increasing. So it's increasing from 0 to 50. So where are my possible maxes and mins? Where?
10.
10 and 50. When is my graph decreasing? When is my original graph going down? 0 to 10. Then what happens after 10? So when it goes from decreasing to increasing, bless you, decreasing to increasing, what happens at 10? Decreases to increase. What's 10 going to be? Decreasing to increasing. What does that produce? A minimum.
Local.
So we have a minimum, a local minimum at 10. Increasing to decreasing. Increasing to decreasing. What do we have at 50?
Max.
A max. So by looking at the derivative, we can figure out that we have a local min at 10 and a local max at 50. And we can estimate what this original graph will look like. It's negative when it's decreasing. So before month 10 and after month 50 is where it's decreasing. When it's increasing is between 10 and 50. 10 is a minimum because it's decreasing then increasing. 50 is a maximum because it's increasing then decreasing. And if I want to graph the original, I'm assuming the original looks like this. Between 0 and 10, it decreases. Between 10 and 50, it increases. And then after 50, it decreases. So by looking at the derivative, I can find out things about the original.